Hello, good day everyone. We are from Group 2 and we are going to present about resistivity and conductivity logging tools. Hello, my name is Victoria, so I will be presenting on introduction and resistivity theory. For introduction part, the surge or economic growth of oil and gas starts with the determination of likely geological provinces, development to seismic surveying, and the wildcat wells drilling operation. If these wells contain oil, wireline tools are used to measure down the hole. This is to determine whether enough oil is present and whether this oil can be produced. There are numerous databases of information available, and wireline logs are one of the main measurements. Glover once mentioned in his 2014 Petrophysics notes that wireline log data and experiments data that have been conducted on cores extracted from the well are widely used. So Schlumberger once describes wireline log as a constant measurement used for formation properties. This wireline log uses electrically powered instruments to assume properties and decide on drilling and production operations. A log is the record of measurements, and it is typically a long strip of paper. And, resistivity logs, which are the electrical well logs, are one of the data types for the wireline log source. A resistivity logging refers to a well logging method where rock or sediment in a borehole are classified by measuring the electrical resistivity. Okay. For resistivity theory part, Amir Abdelaziz in 2016, he once describes resistivity as the degree to which the subsurface prevents current flow from passing through. Resistivity measures the resistance of electric current flow along with the electric properties of a formation. The SI unit of resistivity is the ohm meter, and it can be expressed as the Greek letter rho. So finally, resistivity has the capability to conduct electric current, but it depends on the volume of water, temperature of formation, and salinity of formation. That's all for me. Thank you.
Now we talk about the borehole environment invasion profile. It's a wireline logging that has single clearly defined purpose is to give accurate and representative data on the physical properties of the rock formation and encounter in a borehole. So the tools to take the reading have to cope with extremely tough conditions downhole, which is high temperature, pressures, inhospitable chemical conditions, physical constraint by the physics measurements, and borehole geometry. And its act of drilling the borehole is the most disturbing thing that can do to our formations of lateral logs, and it works best in saltier muds or in a normal muds in high resistivity formations, and it does not work in airfield or cast hole, and it produces reliable resistivity measurements in boreholes, contains high saline drilling fluids or surrounded by high resistivity rocks. This is the figure of basic lateral logs, and next figure is the dual lateral logs instruments. This dual produce a deep investigation resistivity and a shallow investigation resistivity measurements. LLD mode operates just like a LL7 tool, but with the same bucking currents that are emitted from A1 electrodes. So the result focus the current from electrodes. While for the LLS modes, it operates the bucking current must veer away from the pathway into the formations and back towards the tool. A2 electrodes cannot constrain the current being emitted from the central electrode too much. Next, I will talk about the principle of microresistivity. A flexible oil filled microlog pad is pressured against the borehole wall by arms and springs. The curves identify permeable formations. Quantitative inferences of permeability are not possible. So the application of microresistivity is used qualitatively to detect permeable intervals with a fine vertical, but not for evaluation of RXO. So the measurements compares two space devices with different depths of investigations, and it providing resistivity measurements of small volumes of mud cake and the formation adjacent to the borehole. So the market is identified by a positive separation of the two curves. So this is the figure of micro-resistivity. That's all for me. Thank you.
My name is Fiona and my ID number is TH18028. So I'm going to continue on the part of resistivity tool limitations. Each type of resistivity tools has its own physical limits. Even with an ideal data set calculated in perfect borehole condition, the uncertainty in the resistivity to response inversion is a problem due to the limits imposed by tool physics. Resistivity tools can be divided into three characteristic types, which are induction, lateral lock, and micro-resistivity tools. For induction tools, it does not work in all base maps when it is in shallow measurements, and it is not recommended when the sheet resistance is more than 250 ohm meter or RMF over RW less than 2.5. For lateral lock tools, it is not recommended when the RMF over RW more than 2.5, and it also does not work in all base mud. While for micro-resistivity tools, it only does not work in all base mud. Lock can also measure the conductivity. Therefore, it is often called conductivity lock. Initially, it is used in the boreholes where the drilling fluid was very resistant, but however, it gives the greatest application in wells drilled with freshwater-based muds. Basically, it helps to see the more conducive zones. But however, the skin effect is a concern that happens with very conducive formation that could contribute to signal reduction. The resistivity logging tools have been developed by integrated service providers which provide a modern instruments like the transmitter and receivers with several components and provide valuable information on directionality in the identification of physical parameters. With these new instruments, it has found a major applications in geosteering and placement operations. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is AMIRAH binti Ibrahim, TH18034, and I'll be presenting about calibrations and log quality control parameters. So what is log quality control? So log quality control can be defined as a set of methods that analyze data that deviates from the standard. So there are a few criteria that need to be checked carefully, such as tool calibrations, depth control, tension, caliper, gamma ray, resistivity, spontaneous potential, density, neutron, and sonic. So any changes or abnormalities in these criteria or response, so it should be clearly explained on log for interpretation purpose. RT determination. So RT determination or true resistivity is the resistivity when it is not contaminated by drilling fluids. So during drilling process, invasion of filtrate water from drilling fluid can happen in the formation. So its resistivity will change to greater or lesser or equal to RT. So there are two steps to obtain RT or to determine RT. So first is to read the resistivity log with the deepest investigation, and secondly, use this table to make corrections. The next part is the conclusion. So to sum up, logging methods and tools are very important in oil and gas industry as it is used to measure the electrical, resistivity, conductivity, nuclear, acoustic, radioactive, electromagnetic, and etc. So a log is quite important as it records changes in measurements or any abnormalities that happen. So we also learned that every logging tools covered different theory of operations, different limitations, and have different advantages and even different application in this industry. So with that, I thank you.